we'll start with the next point, that is friction in a worm and worm gear pair. Now basically what happened at the time of meshing of worm and worm gear, there are two motions, one is sliding and second one is a rotation. So sliding will be occur in between the threads of worm with respect to worm gear, correct. So that will be the sliding, and sliding is somewhat dominated. So because of that sliding, there is a friction generated at the time of meshing. So you can see this diagram I have drawn. This is worm wheel and this will be the dotted portion is worm. So in that, the forces which can be shown, see here, the forces of the worm wheel, it is perpendicular, that is Vw, and on the gear it is Vg, which can be shown here, Vw and Vg, and with respect to lambda, this is lead angle, lambda, correct. So this will be the lead angle. Now the resultant of this will be the sliding velocity, because of at the time of meshing it required, so that indicate by Vs. So very simple, this can be asked for the derivation. I'll write directly the equation, you can see from the triangle. Now let us one by one I tell you. Vw is nothing but pitch line velocity of worm, Vg is pitch line velocity of worm gear, and generally velocity pi dn by 60. If I want to calculate in meter per second, I can use 16 to 10 raised to 3 here, correct. So here simple formula pi dwi, because I need to calculate for worm. Here in terms of the gear, why I want to calculate for pitch line velocity of gear. Vs is the sliding or rubbing velocity. Now you can see the triangle, and I can use direct equation. Cos of lambda, see this, cos of lambda is equal to Vw by sliding velocity. Same, if I take the sine value, that is Vg by Vs. So this will be the values. If I want to calculate resultant, of course resultant is nothing but the square root of vertical force square plus horizontal force square. So directly we'll get the sliding velocity. So this kind of the friction we can calculate by this sliding velocity Vs. Understood? Okay, we'll go to next slide, that is efficiency of the worm and worm gear. Actually what happened, I'll directly tell you the trick for this. So efficiency of power screw, which we had calculated, if you remember, n is equal to, efficiency is equal to tan of alpha divided by tan of phi plus alpha. So likewise we have calculated. So same efficiency here is also same, because worm is structure same as that of screw, correct. Now here somewhat detailed explanation I have given, you just go through it. Efficiency is nothing but output by input, that output is PO by PI. Now for that, PO is nothing but the output power. You can calculate power is equal to tangential force, Ft is equal to P by V, then power is equal to Ft into V. So I have written here Ft into V, you can see. And input power, again this is for gear, output is gear, because gear is given the output, and therefore worm Fwt into Vw, that is tangential force on worm. So Fgt as it is, because it is tangential force, Fwt worm gear, it is tangential force. Now velocity we need to convert, which we have seen in previous slide, pi dn by 60, pi dn by 60. So by common terms I get cancel 60 and all that, I'll get the efficiency is equal to Ft dg into ng divided by Fwt dg nw dw, correct. So simplify in this simple format, you can see the dg is equal to m into zg, and dw diameter of worm, that is m into q. So m get cancel, I'll get m get cancel, I'll get zg by q, that is the value of dg by dw, this value. See, this value I have calculated. Then as we know, the dg by gear ratio is nothing but zg by zw, that's why we can use the dg by dw is equal to zg by zw into, that is multiply and divide by the zw, I'll get zw by q, this will be the value. Now for this case I can write easily, you can see here dg by dw is equal to, this is gear ratio g, and zw by q, this is tan of lambda, which we know in terminology. Therefore RPM of gear divided by RPM of 1 is 1 by G. So if I take reciprocal of this, then I'll get 1 by G. So same, I'll put the equation C, FGT as it is, this equation. dg by dw we have converted, so that's why it is G tan lambda lead angle divided by, so I have converted this RPM, that's why it was 1 by G. So I have mentioned here 1 by G, so you can see 1 by G, correct. So efficiency is equal to FGT into tan of lambda, G get cancel, tan of lambda FWT. So therefore FGT is equal to FWT, tangential force on worm. So that term we have selected here, and through which we'll have to get, that is FGT value, that is FW by FA. See, very important, FGT tan lambda, we'll have to convert FGT is equal to FWA from the diagram into tan lambda divided by FWT. Therefore FW is nothing but FWT divided by tan of 5e friction angle plus lead angle into tan of lambda divided by WT, FWT, that is worm. Therefore by cancelling the terms, I'll get directly the value of efficiency, tan of lambda divided by tan of 5e plus lambda. As I told you in power screw, what happened, tan of alpha divided by tan of 5 plus alpha. Instead of that, in alpha converted into lambda. So directly we can write, just remember this, efficiency is equal to tan of lambda divided by tan of 5e plus lambda. Now 5e is very important. I told you 5e is nothing but what? 5e is nothing but tan inverse of mu v. Did you remember? 5e is nothing but, see, I'll write here, 5e is nothing but tan inverse of mu v, and mu v we know, mu v is equal to mu by cos of phi n, correct. So likewise we need to calculate this 5e, clear. At the time of solving numerical you will get this, correct. So by this way we can calculate the efficiency. Derivation not asked yet, but you must know how it calculate, that's why I have explained. So efficiency is tan of lambda divided by tan of 5e plus lambda. So this is the efficiency term. Next we'll move toward the material of the worm gear. Very basic things are there. Generally, as I told you, for worm gear we are using cast iron because it can be directly used by the casting. Phosphor bronze also we can use, and in case of the worm, that is material of worm, we can use steel because it's the smallest part, and it should have the maximum strength to sustain the number of starts load at the time of rotation or engaging the teeth at high loading condition. So basic property of the worm material, I'll tell you. I'll start from the worm. This is the material of the worm. First table, it is a worm. So generally worm is having high fluctuating stresses, repetitive contact stresses. So to sustain this, or to sustain bending stress also, endurance strength also, worm gear should have maintained the strengthened characteristic. So it can be maintained only by the using ductile material, that is steel. So the chart is given over here. I'll explain one, that 40C8 percentage of carbon, 40C8 580. This will be the ultimate tensile strength for the BHN of 220 and so on. So such kind of the material is used. So this structure is for worm gear. So in case of the gear, grey cast iron, phosphor bronze, gun metal can be used as a worm structure. Clear? Many time what happened, one gears are broke, so that can be easily cast or directly get from the at the time of breakage. But in case of the worm, we need to check it, the parameter we need to develop or manufacture. So again, the costly and all that. That's why worms are always made up of steel.